So in this lesson, we're going to talk about how to find absolute max, absolute min when the extreme value theorem is applicable. All right, so the first example I have it here, we already did it in class, so I'm not going to repeat that. So let's look at the first example for this video. First of all, you can see we are given an interval, right? We want to find absolute max, absolute min in a given interval. And we've got a closed interval, okay? And the domain of the function is x not equal to 0. And as a result, well, you can see 0 is not included in the closed interval. Therefore, the function is continuous, on the closed interval. So according to extreme value theorem, the absolute max and absolute min, the absolute max and min both exist. So our job, we need to find it. We are going to find these absolute max, absolute min. The first step, we're going to find the critical numbers. Okay, so step 1 is to find the critical numbers. Okay, to find critical numbers, we're going to take a derivative of the function. The derivative of x is 1. The derivative of 1 over x is negative x squared. We got the derivative and we set it equal to 0, right? So you can say set the derivative equals to 0, and what do we get is we're getting this equation. We're going to solve this equation for x, right? So adding 1 over x squared on both sides, so that 1 equals to x squared. And because x is positive, we're doing all of these things inside the closed bracket, inside the intervals. So there's no issue of 0 equals 0. So multiply both sides by x squared, so x squared equals to 1. And x squared, when we take square root on both sides, right, the square root of x squared equals to the square root of 1 is 1. And the left-hand side is absolute value of x. And the equation, the solution to x, absolute value of x equals 1 is x equals to positive 1 or negative 1. So we have two critical numbers. But if we notice the negative 1 is not in the interval. Okay, negative 1 is not in the interval, not in the given interval. And therefore, the only critical number we have here, we only have 1, okay? Which is, you can use C, or you can keep it x is positive 1. So now we are on a closed interval. We have 1 critical number, and then we have 2 endpoints. So we're going to be testing for absolute max and absolute min, okay? So we're going to be test for absolute max or min. And what do? We have 3 numbers, right? C equals to 1. And we also have the 2 numbers on the closed interval. So 1 is, so we use A equals to 0.2, and B equals to, these are the endpoints, B equals to 4, right? And we're just going to plug in the function, the original function, not the derivative, okay? Because we were looking for the absolute max and absolute min for the given function. So we're going to plug in this function to see we get the maximum or minimum. So for 1, we plug in 1, f of 1 equals to 2. Okay, and for f of x equals to 0.2, and x replaced by 0.2, and that's 0.2, and that's 0.2 plus 5, right? 1 divided by 0.2 is 5, so we get 5.2. Third one, the third point is 4 and 1 over 4. Okay, replace x by 4. And for this one, we got, of course, it's a 4.25. So among these 3 numbers, which one is the largest? Obviously, this is the largest, right? So this is the max. So this is the absolute max. And what is the smallest? The smallest is 2. So that is the absolute value, absolute minimum. And we're done. We're done with this question, okay? So you can answer the question saying, this is the absolute max. So you can say the absolute max and the min are this. And f of 1 equals to 2. And it's done. It's done. Okay, let's look at the second one, the second example. Okay, the second example, of course, we are given a closed interval once again. So first, we need to determine what is the domain. Okay, to determine the domain, right, we need to know that if the closed interval is inside the domain. If it is inside the domain, then the function is continuous, and therefore extreme value theorem would apply. So to find the domain, we're going to set the denominator equals to 0, right? And we know that this is a quadratic function. If we look at the discriminant minus 4ac, it equals to -1 squared, subtracting 4 times 1 times 1. And this is going to be negative. And this negative tells us that this equation does not have a real number solution. Okay, so no real number solution. We have we have 2 complex number solutions. But what does this tell us? This tells us that in real number, okay, so this piece is not equal, will not be equal to 0. It will not be equal to 0 for any real number. For any real number. And that is to say that this function is defined everywhere. That is, okay, so this function is, the domain of this function is everywhere, is defined on all real numbers. All real numbers. And as a result, right, when we only look at this interval, the function is, thus this function is continuous on this closed interval. And then extreme value theorem applies. That is absolute max and min exists. Okay, so we're going to set out to find it. How do we find it? Of course, we're going to find derivative, right? The derivative is going to be applying quotient rule. Okay, so derivative of x equals to 1 and multiply the denominator, subtracting x multiply the derivative of the denominator, which is going to be 2x minus 1. Simplify this expression, right? We're getting, let's just copy and paste, and then so we don't have to type the denominator all over again. So one time that can be omitted, and x times 2x, that's going to be 2x squared. And so we're going to have 2x squared, right? That's negative. And x times negative x times 2x is negative 2x squared. Negative x times negative 1 is going to be positive x. So one more step. We're going to combine the like terms. Okay, negative 2x squared combined with x squared. So we're going to have negative x squared left. Negative x and positive x makes zero. So we basically have negative x squared plus 1. Okay, if you like to write it differently, you can switch these two by bringing 1 in the front. So 1 minus that. And next, we're going to set the denominator equal, we're going to set the entire derivative equals to 0. Okay, when we set the entire derivative equals 0, the denominator cannot be 0, right? Denominator, as we said, it will never be 0 in this case. So for the derivative equals to 0, the numerator must be 0. So that's how we get the next step equals to 0. Solving this equation, we've done something similar earlier, right? X squared equals to 1. We did this before. So we just copy paste and this whole thing, right, step by step. And that's what we have. Okay, so we get 2 critical numbers. But we want to double check if any one of the critical numbers is in the interval indicated, and the negative 1 is not in it, right? Negative 1 is not in the given interval, so we can just drop it in the given interval. So just one critical number. That one critical number is a positive 1. Okay, so now we're going to test. We're going to test absolute max and min on 3 numbers. C equals to 1. Okay, and the endpoints. A, B. A equals 0. B equals to 3. Right? And the function we're going to be testing with, and we're going to test it, of course, on the original function. Okay, we're going to test it on the original function. And so once again, the same drill. Okay, so these 3 points will be tested on input 1, right, where x will be replaced by 1. On 0, right, x will be replaced by 0. And on 3. So 3, 3, 3. And this one, of course, that equals to 1. And this is 0. And this piece equal to, let's just have little patience with our calculation. So this is 9 minus 3. That's 6. 6 plus 1 is 7. We got 3 numbers. Which one is local max? Which one is absolute max and absolute min? You compare 3 numbers, right? 0 obviously is the smallest. So this is absolute minimum. And 1 is absolute maximum. Okay, done. Okay. You can, usually we prefer you just have a closure. Okay, have a closure by writing, say, the absolute max. The absolute max is f of 1. Whoops, f of 1 equals to 1. Okay, the absolute min is, oops, the software is a little, absolute min is f of 0 equals to 0 found. Okay, so let's look at the next one, example number 3. Okay, I pick up all of these questions from homework, and they're all number questions. All right, first of all, the domain is all real numbers, and this is a closed interval, and obviously f is continuous, right? So you say f is continuous, on the closed interval. Okay, so extreme value theorems applies. Okay, that is, they are absolute max and absolute min in the interval. So we're going to go about to find it, right? So we know we're going to test the endpoint, but we also need to find the critical number. So let's find the derivative. So we can find the critical numbers. The derivative of x is 1. The derivative of cubic root of x, then we can write it as 1 over 3. I would take a derivative of x to the power 1 over 3. So that's going to be, you take 1/3 down, we apply power rule. We apply power rule here, and 1/3 subtract 1. Okay, so right there, you get x minus 1/3 of x raised to the power of a negative 2/3. Okay, and of course our next step is we're going to we try to get a factor form. But in derivative in the given interval, there's no points that's undefined, right? So it's differentiable, no problem, right? We just go ahead to set it equal to 0. Okay, so we can just set it. So it can be done this way too. Okay, set it equals to 0. So we're solving this equation, right? So this equation will lead to the next equation. So that's equals to 1 over 1 equals to that. And then you're going to multiply 3 on both sides, right? And then you have 3 equal to x raised to the power of negative 2/3. Okay, and then because this is a cubic root, so you're going to write it down as 1 over x raised to the power of 2/3. Okay. All right. So then you can see this as 1/3, 3/1. So you take this piece and multiply 3. So you have 3 multiply x raised to the power of 2/3. That equals 1. Okay. And then what do we get? Well, we can just divide both sides by 3, right? After we divide both sides by 3, x to the power 2/3 equals to 1/3. And then what do we do? We're going to power 3 on both sides. Okay, so we're going to power on both sides by 3. Power both sides by 3. 3. Okay, on the left hand side is going to be x squared, right? Because this is 3, sorry. This 3 power is going to multiply 2/3, and 3 and 3 reduce, right? So we have x squared equals to 1/27. And next, we're going to take square root on both sides, right? I'm going to take square root on both sides. So it's a similar drill as this one, okay? Except the right-hand side is not 1. Okay, the right-hand side is not 1. It's 1/27. So this is 1/27. 1/27 being taken square root. And what does that equal to? 27 equals to 9 times 3. So we have 1/3 of root 3. Okay. We can rationalize it later. But we got 1/3 times root 3. So in the end, this is what we got. Okay, if you rationalize it at this point, if you rationalize it, you would multiply root 3 on both top and bottom. You multiply root 3 on both top and bottom. So, and this 3 times that 3, that makes 9, right? And I'm sorry, that makes 3, and 3 times 3 is 9. So in the end, you get root 3/9. Positive, negative. I think our interval does not include. Oh, it does. Okay, so this is the interval we have. Okay, the interval we have, A is -1, B is 4, and we have 2 critical numbers. We have 2 critical numbers. Okay, so C1 is equals to negative root 3/9. C2 equals to root 3/9. So we have 4 numbers to test for absolute max, absolute min. Okay, so we're going to bring these 4 numbers in comparison. The first one is -1. Okay, so x replaced by -1, -1, and -1. Okay, so you calculate it. This is going to be equals to, so the cubic root of -1 is -1. So -1 subtract the -1, that's going to be 0. Okay. And the second number is 4. Okay, so it's 4, 4, 4. And the third number is negative cubic root, negative root 3 over 9. Negative root 3 over 9. It looks like we're going to need a calculator, don't we? And positive root 3 over 9. Okay, you have my permission to use a calculator. But so here, this one, you're going to use a calculator. And that we can use a calculator. And that one we're going to use calculator. Which one is the largest? It looks like this is the local max. This is absolute max. Okay, that's the absolute max. What is the absolute min? It looks like this one is absolute min. Okay? Okay, so let me speed up a little bit. Okay, I don't want to make this too long. I have 3 more questions to go. I wish to cover different types of questions, okay, you might encounter. Trig function evolved. We have a closed interval. Trig function continues everywhere. So obviously we're going to say f is continuous, right? On the closed interval, right? And thus extreme value theorem applies. There exists absolute max and absolute min. So then we just set out to find them. We set out to find them first. We already have the endpoints. So we just have to find the derivative to find the critical numbers. So the derivative of cosine x is a negative sign, right? We put a parentheses about it. The derivative of sine 2x is cosine 2x and multiplied by 2, right? And we're going to set it equal to 0. Set it equals to 0. If we set that equals to 0, we're solving this equation. We're solving this equation. How do we solve this equation, right? So here we're going to write negative 2. How do we solve this equation? Remember, cosine 2x is equal to 1 minus 2 times sine squared. Okay, that's a double angle formula. Okay, once we have that, we are going to solve it. Okay, so negative 2 sine x plus 2 minus 4 sine square of x equals to 0. All right, so we have 2 to multiple of, okay, so we can divide every term by 2. Okay, if we divide every term by 2, the right hand side will still be 0. The left hand side will have a 1 here. This is going to be 2. Let's rewrite it. So I'm going to arrange it by the order. Okay, so over here, subtracting sine x plus 1 equals 0. Doesn't this look like a quadratic function? Except that the sine x is being tweaked, right? And if we if we divide it by negative, divided by -1 here, we are going to get 2 times sine. Okay, divide by negative. So I just want to divide by negative, right? So we're going to get 2 times sine square x plus sine x minus 1 equals 0. You can see this, you can treat this as a quadratic function, 2u squared. Oops. 2u squared plus u minus 1 equals 0, where u equals to sine x, right? So we can factor this, right? Let's factor this. If we factor this, it can be factored like that, okay? So now we got u plus 1, which is sine x plus 1, multiply 2 times u, 2 times sine x minus 1 equals to 0. Okay, use your factoring technique. If your factoring technique doesn't work, use quadratic formula. You're gonna get here, okay? Because I don't want to make this too long. If you have issues with factoring, ask me in class. We have this product, right? So sine x by this time, we can apply principle number 5, that equals 0, or 2 times sine x minus 1 equals 0. Okay, now sine x equals to -1, or on this side, sine x equals to 1/2. And our interval is from 0 to pi over 2. So we don't need to find all the solutions on the entire number line. So note the interval. Okay, so I just want to bring it here. So note the interval of concern. Okay, so we're only concerned about this interval. Well, on this interval, solution on this interval, obviously, this x is going to be what? This x is going to be negative pi over 2. Negative pi over 2, but that's not in the interval, right? So it's not in the given interval. How about the other one, right? So for that one, for sine x equals to 1/2, x will be equals to pi over 6. Okay, another solution will be 5 pi over 6, but 5 pi over 6 is not in the interval, so we only have one. So one critical numbers. Okay, so critical numbers, right? We have how many? We have just pi over 6. You can call it C if you want. We can keep it as pi over 6. So next we're gonna test absolute max, absolute min. Okay, so test the function for absolute max min, right? They both exist. So the number we're going to be testing, one is A is 0. So besides C equals pi over 6, I'm sorry, I'm trying to speed it up. Okay, so A equals 0, A equals 0, B equals to, sorry, that's lowercase a, lowercase b, to be consistent with the notation. in extreme value theorem. So we're testing on these three quantities. Okay, three values for absolute max, absolute min. So I'm going to plug in pi over 6, pi over 6, pi over 6. Okay, so this put in parentheses. Now, cosine pi over 6 is root 3 over 2. Okay, so 2 times root 3 over 2. Okay, and the plus sine 2 times pi over 6, that's sine pi over 3. Sine pi over 3 is root 3 over 2. So what do we have now? We basically have 3 times, right? 3/2 of pi over 3. Root 3, sorry, root 3. Okay, so that's number. And 0 times 0. So that's going to be 0, and this is going to be equals to 2. Cosine 0 is 1, so this is 2. And the next one is pi over 2. We're going to plug in pi over 2. Pi over 2, cosine pi over 2 is 0. Sine pi over 2. Okay, sine of 2 times pi over 2, that's sine of pi. So both are 0. So this is 0. 0. So let's see which one is bigger, which one is bigger, which one is larger. Obviously, this is the smallest, right? So this is ABS min. But which one is larger, right? Let's just use a calculator to find the numerical value. So this is the absolute max. You can still detect it without using calculator. So this is absolute max. Okay. So that is finished. That is done. Let's see, we have 2 more. Forgive me, this is a bit too long, but I do want to cover these questions. I anticipate that you might need help. Derivative. Okay, so first look at the domain. The domain of this function should be x is greater than 0. Okay, required by ln x. X cannot be 0, right? But the interval does not include anything that even close to 0, so we don't have to worry about. So the function is continuous. Okay, so continuous on the closed interval. On the closed interval. So all the wordings we said earlier, I'm going to copy and paste. Okay, so get it done soon. Okay, so you want to have that kind of, you know, at the beginning of your question, you have like overall, so the reader know what to expect. And then derivative. Okay, derivative, you can view this as ln x over x squared, really. Okay, so that you do quotient rule. You can do product rule if you want, but I'm going to do quotient rule. So this is going to be x squared and squared. Okay, the derivative ln x is 1 over x. Okay, and multiply x squared, subtracting the derivative denominator is 2x, and multiply ln x. So what you get now, what we got by this time is gonna be, this is gonna be x raised to the power 4, right? And x squared multiply 1 over x, that's gonna be x. So that's what we got, 2x times ln x. I'm gonna set it equal to 0. Set it equals to 0, right? Denominator cannot be 0. Well, x is from here, so denominator will never be 0. So for the derivative to be equal to 0, the numerator must be 0. But for the numerator to be equals to 0, let's do some factoring. Let's do some factoring, okay? No sweat. X can be factored out. So inside is going to be 1 minus 2 times ln x. Okay, so when we set the whole derivative equals 0, that means this product is going to be 0. If this product is 0, that means x is going to be 0, but you can see x equals 0 is not in the domain, in the given interval, so we don't need to worry about it. The next one is that is equal to 0. So this is not in the given interval, so we're going to drop it. All right, so we're going to drop it. So we just have to solve this piece. Do we know how to solve this piece? All right, so we're going to solve for x. Solve for x. So what do we get? We got 2 times ln x equals to 1. And ln x equals to half. Equals to half. Now what is x equal to? X equals to e raised to the power of half, which is square root of e. Square root of e. So that's our critical number. That's our critical number. Our critical number is the square root of e. Okay? And that's the only critical number. So then next we're going to test, right? We're going to test it. You can use either one. So test for absolute max and the min. Okay, the same drill. So the function is here. You can use whichever you want. You can use this one or you can use that one. But we're testing on C. Okay, and we're also testing on A. A, what does A equals to? The interval, right? The interval half and 4. So A is half and B is 4. Right, so we're going to plug in each one of these numbers one by one. So root E, well, let's use this one. Root E, right? Boom. And root E. And this piece is squared, right? Root E squared, that's going to be equals to E. And the natural log square root of E equals to half. So in the end, it's 1 over 2E. Okay, for half, for A equals to X equals to half, we can use this formula instead. Okay, we use this formula instead. So half, and this is what? Half, right? 1/2 raised to the power -2. That should be 2 to the power -2. So it's going to be 4, right? Flip over. And ln 1 over 2, that's going to be equals to ln 1 minus ln2, quotient rule, right? That's going to be 4. ln1 is 0, so ln2, so that's going to be negative 4 times ln2, right? That part should not be hard to understand, and the last one is 4. Okay, so which formula you want to use? Doesn't matter, let's use this one. Okay, use this 4, and this is 4. And that's 2 times ln2 over 16 equals to ln2 divided by 8. So which one is the largest? Which one with the size? Obviously, this is going to be absolute min, right? But the question is, which one of these is larger? So try the numerical value. It looks like this one is 0.08, and this one is larger, right? So this is absolute max. Okay. All right. Last one, not least. Okay. Yeah, you can read it. You can read it. You can play and read it. All right. From -1 to +1. Okay, the domain. This piece is, inside the parentheses is positive. Okay, it's a quadratic. And so we can, this quadratic is totally positive. Therefore, we don't have to worry about domain. And for this particular interval, we can also say that once again, that f is continuous. Okay, I'm just copying and paste. F is continuous on -1 to +1, and therefore extreme value theorem applies, and there exists absolute maximum and absolute min. Okay, I think this one, you just find the derivative. Okay, derivative of ln of that, so it's 1 over, we're going to apply chain rule, so 1 over that, and derivative of the x squared plus x plus 1, that's going to be 2x plus 1. And we set it equal to 0. And the denominator is never going to be 0, so it's going to be 2x equals 0. So 2x plus 1 equals 0. So the critical numbers are x equals to -½ -½ is in the given interval. So we're going to test for absolute max, min. They both exist. And we're going to test it in this function. Okay, 3 times. So the point we're going to test -½ Okay. A is, what is A? -1. B is +1. Okay, let me double check. Yep. You plug in. Okay. So -½ plugged in. Replace that. Oops. -½ squared. -½ Boom. Okay. The next one to be tested at the function x is replaced by -1, -1, and -1, +1, +1, +1, +1. Okay. So this is ln3. And this is ln positive 1 minus 1, that's ln 1 equals 0. And this piece equals to ln, this is a quarter, right? A quarter plus negative half is, let me write it down. Okay, so this is a positive 1/4 minus half. Okay, let's do 1 negative half plus 1, that's a positive half, right? So that's going to be plus positive half, right? So in the end, what do we get? We get ln, we add these two numbers, so this is the 4/2. So this is going to be ln 3/4. And that's ln 3 subtracting ln 4. Which one is larger, right? This is ln 3. And this is ln 3 subtract something. It's definitely negative, right? So that is going to be the absolute min. And what's the absolute max? Absolute max is this guy, right? 0 is between a negative and positive. All right, I hope this is not too long, but I suspect it's going to be long. Watch it by taking breaks, but do try your best to improve your not only calculus but also algebra. You can see algebra plays a very important role in all of these works. All right, thank you for watching. Have